one of the things that we do in grade 12 pre-calculus is we extend angles beyond 360 degrees. So usually when you start trigonometry in grade 10, you're only up to like 90-degree angles and right-angled triangles, and they would say, oh, it adds up to 180 degrees, but that's about as far as you go. Then grade 11, you go all the way around, introduced to the cast rule and go to 360 degrees. In grade 12, they just say, well, you could go around as many times as you want, so our angles become as big as we want, and we also do it in radians and degrees. So one of the things we have to do is when we see a big angle, like 4,300 degrees, we want to find out, well, what's its reference angle? What quadrant is it in? What is it coterminal with? So these will be things that we'll be thinking about and figuring out today. Now, if you had a calculator, and this first one is done with a calculator, if you wanted to figure out what quadrant 4,300 degrees is in, you could divide by 360 to find out how many rotations it's done. And it comes out to 11.94. So it's 11 full times around, and then almost another full time around. So this 0.94, does it make sense that that would be in quadrant 2, because this is a quarter of the way around, this is halfway around, this is 3/4 of the way around. If I'm at 0.94, I'm almost another full time around, but not quite. It's going to end in quadrant 4. That's if I have a calculator. Same thing in radians. You could do the same strategy in radians if I had some angle like 75 radians. I could divide that by 2 pi. Ooh, this is a good thing to point out. I'd like you to take out your calculator. This is the number one mistake that students make. I'd like you to take 75 and divide by 2 pi. Okay? And I'm going to do it in 2 different ways. I'm going to do it this way. And find my pi button. And I'm going to, if you have a graphing calculator, you should check if you have the ability to write fractions. So if you have the ability to write fractions, you can push your alpha f1 or alpha y equals and see if a menu comes up. If it does, and you can write this as a fraction, like this, 75 divided by 2 pi, and push enter. Now, interestingly, I got 2 different answers. So one of them is wrong, or else they're both wrong, possibly. But I want to point out that you will be very tempted to do what I did at first, when I went 75 divided by 2 pi. Doesn't that look exactly like what I said? Doesn't this, in your calculator, look like 75 divided by 2? That is actually, order of operations, 75 divided by 2, get that answer, and then instead of also dividing by pi, your calculator multiplies by pi. If you want to do it this way, where you're just typing it, you would need to have brackets on the bottom, because you want to divide by all of 2 pi, not just by the 2. So that's the number one mistake that often happens. You should get 11.93. So 75 radians. Wow. Okay, sorry. I'm just pure coincidence. That is, I'm amazed that 75 radians is almost equivalent to 4,300 degrees. That is just pure chance. And it's like, I feel like I should buy a lottery ticket, because that seems like that's highly unlikely that I would just pick a random radian and get almost perfectly 4,300 degrees. But if I buy a lottery ticket, my luck's already run out for the day. Oh, sorry, that was terrible. I just wanted to point out that you need to make sure you either, if you're dividing by more than one thing on your calculator, you do have to have brackets on the bottom. But if you have a calculator that allows you to write in fractions, love your fraction button, like I have here, 75 divided by 2 pi, because then you will make less human error when typing things into your calculator. If you have a TI-84 calculator and it doesn't have the fraction button, you can bring your calculator in and I can upgrade your operating system so that it does. Okay, very nice. So, this is with a calculator to find out it's in quadrant 4. Most of these questions are non-calculus. And we still haven't found out what it's coterminal with in the first time around. So I know that it ends here. I want to find out what's this angle. I don't know that yet. I also am kind of curious, what's my reference angle right here? So if you want to find something coterminal with 4,300 degrees, you can just keep subtracting 360 degrees until you get to something between 0 and 360. You could do it slowly, subtract 360 once, then subtract 360 again, then subtract 360 again. But if I was doing this with mental math, suggestion?
You can do 4,300 divided by 360 for the result.
Right, but this is only if you have a calculator. Like I'm saying, if you started off without a calculator.
Or things in your head.
Right. What I would probably do if I didn't have a calculator, I would say subtracting 360 10 times is easy to do mental math. Because 10 times 360 would be 3,600. That would leave me with 700 degrees left. So I know that 4,300 degrees is coterminal, ends in the same place as 700 degrees. Then once I have 700 degrees, I'd probably go from there and subtract another 360. For me, mental math, that would probably be the easiest way for me to get that it's coterminal with 340 degrees without a calculator. And once I have 340 degrees, I now know my reference angle is 20 degrees. So I know it's in quadrant 4, I know my reference angle, I know what angle it's coterminal with. These are going to be helpful things moving forward. More often, though, in grade 12, we start to deal with angles in radians more than degrees, because radians are the preferred measure of angles once you get to higher level mathematics. So if we were doing this question in radians, first of all, the beautiful thing about radians is that when you have negative 23 pi over 6, you can tell right away what the reference angle is. The reference angle, when it's written in this form, is given to you immediately. The reference angle is pi over 6. Super easy to tell that it's pi over 6. Now, we just have to determine what quadrant it's in. Again, if you had your calculator, you could divide by 2 pi to find that. But most of these are going to be non-calculated. And the method that I like to use is writing the improper fraction as a mixed fraction. So this is going back to something from grade 9. Do you know how to change 23 over 6 to 3 and 5/6? You're basically looking, how many full 6s could I get into 23? I could get 3 of them. 3 full 6s would give me 18. I still need 5 more to get to 23. So this is 3 and 5/6 pi. And I have a negative, so there would still be a negative out in front. And the technique that we're going to use to figure out what quadrant it is in, figure out what quadrant it is in, 3 two-letter words all starting with I in a row, hard to say, okay, is by thinking in fractions of pi. So here's your circle. Here's 0. Halfway around is pi. All the way around is 2 pi. But if you kept on going, and you counted by pi's, this would be 1 pi. All the way around is 2 pi. Can you see that this would be 3 pi? Then if you went around a second time over here, you would get to 4 pi. Then this would be 5 pi. And this would be 6 pi. And a pattern starts to emerge. You see the pattern? If no, the next one here will be 7 pi, the next one here is 8 pi. These ones are all even numbers. These ones are all odd numbers. This is where you say, oh, I don't see the pattern. Could you keep going? Can you make me keep going for like 10 minutes? You see it yet? No. Well, this one will be 10, and this one's 9, and then 11, and 12. And the odd numbers are here, and the even numbers are there. So when we have the whole number being odd, -3 and 5, 6 pi. Well, the -3 would be saying, I'm going in this direction for negative. This is 1 pi. This is 2 pi. This is 3 pi. I could draw it out. But if it's a negative, if it's an odd number, you know that you're going to be on your x-axis, the negative x-axis. If it was -13, I wouldn't have to keep drawing it out. I just say, I know that I'm going to be here, and then the 5, 6. You just have to determine, is that 5, 6 more than half or less than half? Because right here is half a pi. And the 5, 6 being more than half means I need to keep going in this direction, but go more than half. I'm going to end in quadrant 1. And so we can use the mixed fraction to quickly determine what quadrant it's in. And then we already know our reference angle is pi over 6. So we're going to be able to say that this is coterminal with pi over 6. What this does then is it lets us do things like, what is sine of -23 pi over 6? In your head, you would think, I know the reference angle is pi over 6. I know that on my unit circle, sine of pi over 6 is 1/2. Right? Because we go to our unit circle, sine is the y-coordinate at pi over 6 family is 1/2. Okay? So you could either go to your unit circle. I would recommend that you memorize sine of pi over 6 is 1/2. If you know that one, you already know that cos of pi over 6 has to be the √3 over 2. Because √3 over 2 goes with 1/2. And if you know that sine of pi over 6 is 1/2, you know that sine of pi over 3 can't be 1/2, so then it's the √3 over 2. So by memorizing one of them really well, and I would suggest sine of pi over 6 is 1/2, you can quickly find out the other ones quite easily. And you're going to have to do a lot of mental math with your unit circle. So either you always have to have your unit circle and go back to it, or you have to think of some strategies to memorize them and say the answers quickly. So for this one, I know that sine of pi over 6 is 1/2. So if I was asked, what is sine of -23 pi over 6? Because it has the same reference angle, I know that the answer is also going to be 1/2. I just don't know if it's positive or negative. So then I have to figure out, well, what quadrant is it in? It's in quadrant 1. Because of my past rule, everything's positive in quadrant 1. So I would know that sine of -23 pi over 6 is also positive 1/2. Okay. So I have a worksheet for you to help you get good at this mental math. See, my luck is running out. I almost grabbed the exact. Okay, we are going to start and do assignment. This page has two assignments. We're going to do sum of assignment 1 and sum of assignment 2 together to get you used to the idea of what I'm looking at for you to do on here. So assignment 1 says, locate the angles, stating your answer in terms of the angle that falls in the first positive revolution of the unit circle. So basically assignment 1, maybe not worded the best way, is finding the first positive coterminal angle. And we're going to do that by finding the reference angle and the quadrant. So it looks like this. Question number 1 has 13 pi over 6. What you're going to think in your head right away is, I know my reference angle. This is part of my pi over 6 family. I just need to find out what quadrant it's in. And I'm going to find out what quadrant it's in by using the mixed fraction. 13 pi over 6 is the same as 2 and 1/6 pi. So I think of a little unit circle, okay? At the beginning, you might actually draw out, here I might write 0, pi, 2 pi. At the beginning, you might actually think about going 1, 2 pi would get me to there, that's the 2. I need to go 1/6 more, so that's going to end in quadrant 1. So to state the answer for assignment 1, we could say that 13 pi over 6 is coterminal with pi over 6. Because what's my pi over 6 family member in quadrant 1? It's pi over 6. Now, when you get to question 5, we'll do question 5 together as well. Question 5 has 101 pi over 4. Okay? So first of all, its radians are really nice. That's part of your pi over 4 family. So you know your reference angle is pi over 4. To figure out what quadrant it's in, we have to change this to a mixed fraction. How many 4s go into 101? Well, 25 of them would make 100, so you would have 25 and 1/4. 25 is an odd number. So you're going to be on your negative x-axis after going 25. At this point, you probably don't want to draw out 1, 2, 3, 4, 5, 6, 7, just circles over and over and over and over again. An odd number tells you it's here. Which direction are we going? We're going positive, so we have been going in this direction. Now the 1/4 is less than a half. So we are going to end in quadrant 3. Knowing your reference angle and knowing what quadrant it's in, you can now say that 101 pi over 4 is coterminal. What is our pi over 4 family in quadrant 3? 1 more than the denominator. So that idea at the beginning where I said you can use the pattern that in quadrant 3 the radians is always 1 more than the denominator, that helps us here figure out that that's coterminal with 5 pi over 4. Assignment 2 says, in assignment 1, it says also whenever there's Sine and cos, you can ignore that. Just think about the angles for assignment 1. The sine and cos is there for assignment 2. In assignment 2, it says, for questions 1 to 8, find the coordinates on the unit circle. And for questions 9 to 32, actually solve what is sine of 14 pi over 3. So it's going to practice your unit circle, which you're going to be having to have memorized for tomorrow. So let's go back to the ones that we did. Question number 1 for assignment 2, and you might want to do assignment 1 and assignment 2 at the same time. Once you know that it's coterminal with pi over 6, you think about your unit circle, and at pi over 6, sine of pi over 6 is 1/2, so I know my y coordinate is 1/2. That makes my x coordinate root 3 over 2. So again, having one of them memorized really well, sine of pi over 6 is 1/2, can help me with this coordinate as well. Okay? For question number 5, it's my pi over 4 family. Coordinates for pi over 4 family are always root 2 over 2, root 2 over 2, and because this is in quadrant 3, they're both negative. So that is assignment 2. We'll do one more. Let's do one with a negative. Let's do 26. 26 has cos of negative 13 pi over 6. So in assignment 1, I would say, I know my reference angle is pi over 6. I want to figure out what quadrant 13 pi over 6 is in. So as a mixed fraction, it would be negative 2 and 1/6. The negative 2 tells me I'm on my positive x-axis. I need to go 1/6 more, which is less than 1/2. And now you have to think, does that mean I'm going to quadrant 1, or does that mean I'm going to quadrant 4? Well, if you're going in the negative direction, right, negative 13 pi over 6 is going in this direction. We are going to be in quadrant 4, right? So we could say for assignment 1 that negative 13 pi over 6 what's our quadrant 4 pi over 6 family? It's coterminal with negative 11 pi over 6. Then I would figure out what is cos of negative 13 pi over 6. It's going to equal, well, it's in quadrant 4, it's positive. Since sine of pi over 6 is 1/2, cos of my pi over 6 family is root 3 over 2. No, because 11 pi over 6 is this angle. And it ends in quadrant 4. And it's coterminal. Coterminal means two things that end at the same place. Negative 13 pi over 6 would be this blue one that goes like that. And they both end at the same spot. Good?
It's not negative, it's positive?
No.
Okay.
So the negative 13 pi over 6 is coterminal with positive 11 pi over 6. Because 11 pi over 6 is going around in the positive direction. And they both end at the same spot. So I just wanted to do one question that involved a negative. And practicing this really gets you used to your unit circle and gets you used to dealing with coterminal angles, reference angles. We don't have a lot of time in this course, but when things I feel are really important, I will give you time to work on them, and this is one of them, so we can have the rest of class to practice this and see how good you can get at this mental method.